Yes, interesting IoT stuff being worked on by PJ and the community and Simon.
Yeah, I just saw some posts today, but I wasn't able to follow up on this. Hopefully I can do it after the call. Okay.
Yeah. Oh, cool. I can even see it on my screen on my phone now.
Nice.
Last time I did one of these on the phone, I wasn't able to see the screen shares.
Yeah, I mean, these apps get better all the time, so.
Yeah, that's for sure.
Okay, we have, how many? Well, a few participants here. They're still joining, so I guess I suggest we wait a little bit more. So
yeah, a couple of minutes for everyone.
Yeah.
Hi guys.
Hey Sam.
Good.
Hey, how's it going?
Good.
Yeah. Good. We're still waiting.
Have you remembered to hit the record button, Chris?
Yeah, thank you, Sam. I did. It's,
Excellent.
It's a big red button and it's shining, so it's okay.
Brilliant.
Hello, guys.
Good morning.
Good morning. This is Fix. Kristjan, you around?
Hey man, I'm here.
Ah, yeah, nice.
Yeah, we just decided we wait maybe a minute or two because people
Yeah, I
are
guess so, yeah.
jumping in the chat. Yeah, and then we can blast off.
By the way, can you hear me well? I mean, with the sound of the audio?
Yeah, the voice is okay. It's
okay,
perfect,
thanks.
At least on my side. So.
Okay, perfect. Thanks.
Yeah, if we start to run out of slots, I can drop off. Otherwise, stay on.
No, we're okay. I think we have 151 slots, so there's still room.
Oh, okay. I thought it was limited to 26 or something.
26 was actually because we were testing the GoToWebinar software for the first time, but on the GoToMeeting, yeah, it's 151, so there's room for us.
Oh, great. It'd be good to see if we pegged 151.
We'll see. Okay. I guess people are not dropping in anymore. So yeah, let's start. I mean, this is our monthly developer roundtable. So based on the topics and the discussions we got from you, we will mostly cover new AIPs. So I'm really happy. We'll be presenting 4 new AIPs. So one will be presented from a community delegate, Mark, which is about Sybil deterrence via relay friction. So he will tell us more about it. He also prepared the presentation. Then we'll cover some bridge chain registration types, which will be introduced into core soon. Then we'll do the hash time lock contracts and the authentication scheme over ARK. And of course, after each of the sessions, we'll have open discussion. So basically, the idea is to present AIP in general, and in the end of the AIP, we want to share some of the thoughts or discussions. We are still not yet strict on the specification. Like for example, hash time lock contracts. Do we want to go with block time expiration, or do we want to go with timestamp expiration? So these are the things we would like to discuss with all of you, and of course get your feedback either during the call, either after the call on our official repository. And in the end, it's an open discussion basically related to any other AIPs. I would really like to keep this meeting developer oriented because we are here to address the new technical features of our ecosystem and move it forward the best way we can. So Mac, you're here. I see you logged in.
Yeah, I'm here.
Okay. So as Mac is presenting from the delegates, so I will give him the first presentation slot. He really prepared a nice presentation, so I'm really looking forward to it. Do you want me to give you presentation rights, I guess? Yeah, just a second. And then you can take it over. Yeah.
So let me know when you can see the window.
It's all good. I can see it.
Okay, perfect. So my latest AIP tries to solve the Sybil attack problem that exists in blockchains. We will discuss what it is and basically what the problem is. The agenda is that we want to discuss, first of all, how identity works, then how that causes the Sybil problem. Then we want to do kind of like a threat modeling. And after that, step by step, we try to build a solution, and finally, we present a solution. And
Okay.
after that, there will be a question section. So if you have any questions, just keep it in mind and or note it down. And at the end, there will be at least, I think, 5 or 10 minutes where we can have a question and answer session. So first of all, how does identity on the internet work? So right now there's a lack of reliable identity on the internet. So for example, if you have an email address or something, that's really a pseudo identifier. It's not really your identity. It doesn't link to your DNA or fingerprint or something. So it's possible basically to create an identity easy and cheap on the internet. And here you can see sort of like a meme that on the internet, nobody knows you're a dog. So this kind of represents what I want to portray here. When you have this sort of a scenario where identities can be cheaply created, you end up with a system where a single person can have multiple votes. So for example, here you can see basically this is a guy who is a puppet master and he has multiple puppets. And there's only one guy who's real here, but even though it looks like there's 5 people here. So that's kind of the idea that I want to portray here. That's the Sybil problem. And this becomes a huge problem in decentralization when you have multiple participants. So because the goal is to remove any center of power, you have to end up using votes. And if you don't know any, for example, if you don't have a good mechanism for identity, then you end up counting multiple votes from the same person as actual votes instead of just one vote. So that's the issue here. So for example, if we try to understand the threats, blockchains are supposed to provide us with consensus. So it is important to agree on a single version of history. And basically we want to avoid forks and we want to resolve forks quickly when they do occur. So for example, if we discuss about proof of work, the fork resolution in proof of work depends on the computation power. So here's like, for example, if we look at a visual representation of that, it's like some new node, or this could be an SPV wallet or something. It asks, hey, what color is the network? And this could be, for example, instead of a color, it could be asking for some value of a transaction, or it could be some block header that represents one of the chains in the network. Mm-hmm. And The other nodes tell it, okay, this is red. These two nodes are telling it this is red. This one node is telling it that it's blue. So it says, hey, I got it. There are two nodes telling me red. One node is telling me blue. So I go with red. So this is possible because there is a verifiable delay function, which is the proof of work itself, that ensures correctness. So there is no way to cheat this. If you want to, for example, overwhelm this sort of a network, you have to have a lot of computational power. But if we try to see the same thing with proof of stake, because of the identity thing that we talked about, since it's not directly depending on computation, now there's a way to cheat this system. So for example, since we just said that fork resolution or it depends on votes, these votes, for example, if you're talking about the network layer in particular, in the case of ARK, these would be the IP addresses or something like that. So there is no simple way to ensure for correctness. So if you try to do the same experiment, ask what color is the network, you would say, okay, if there's no Sybil attack, you would say, you would get the correct value and you would say got it. But if there is a Sybil attack, then this person is pretending to be multiple people, then you would have the wrong value and you would end up on a wrong fork if you were actually following the voting method. So how do we solve this? So basically we want to make it so that it's expensive to maintain thousands of nodes, because right now there are a few, I think at least 100 nodes in the network. So if you want to attack it, you need to have at least thousands of nodes. So we want to make it expensive to have that many nodes. And we want to make it easy to detect the Sybil nodes. And also we want to make it easy to remove the Sybil nodes once they have been detected. So let's build up to a solution. How about we try to tie up a small stake, and whenever a relay operator is starting a relay, they have to, for example, similar to how we give the passphrase of a delegate in a forging node, we can do something similar, but instead it has the address should have like 5 ARK or something. So now every time it is communicating with the network, it says, okay, here's the address that I'm staking from, and anything further basically going on, it has the stake there. As long as the stake is there, this relay is considered valid. So if the stake is not valid, then you basically remove the network from your remove the peer from your network. So you ostracize it, and you communicate this proof that the relay doesn't have a stake anymore or something. So basically all the nodes on the network know that, okay, this relay is not good anymore. They remove it. So if the relay provides bad information, then slash the stake. This will be done by the forging nodes. So what are the shortfalls here? Well, we discussed about stake, but if there is something, for example, if there is an SPV wallet, or if there is something that's using the API, then they don't really know if the stake is valid or not. So how do we solve for that? Well, we add a rare rebroadcast. So for example, once out of every 100 interactions that you do with a relay, you just broadcast 1 out of every 100 out to the network. And if they were not valid, they would get caught. So this is kind of like a probabilistic safety approach. So the number n can be adjusted based on how many peers are there in the network and so on. So still, what are the shortfalls? Well, how would the relays know that the data broadcasted is correct? So well, the relays, for example, the problem here might occur that if I am your client and you run a relay, I get some data from you, I can tamper with it and rebroadcast it with wrong data. So then in order to get you off the network. So this might be an attack vector. So what we do to solve this is we add a signature so that this cannot occur anymore. Okay, so what are still the problems? How do we know that a rebroadcast wasn't censored? So for example, if an attacker is serious enough, what they could do is they could create thousands or maybe even 100,000 nodes on the network and completely eclipse the network, so that any new connection or any existing connection, if they've been doing it for a long time, they won't be able to get the data that you are, or the proof of Sybil attack that you're trying to give them. So that's why we add the proof of work here, and it doesn't have to be a lot. In my AIP, I discussed that 0.1 second proof of work should be enough to deter against this. So what are still the shortfalls? How do we know that this proof of work isn't going to be used for a DDoS attack. Okay, that's why we add the client-side proof of work as well. So the idea here is that while you are doing the handshake or while you are setting up the connection, you both the client and the relay will do a small proof of work just to prove that the client isn't trying to do a DDoS attack by spamming the relay. So what does the end solution look like? It's here. So first of all, the client connects to a relay and both contribute to a nonce. We call this nonce 1 during the handshake. And the client has to solve proof of work using this nonce 1 to prove that it's not trying to do a DDoS attack. The relay sees this nonce and then sees the proof for this and says, okay, now I trust you, so now I'm going to give you the data. And based on this nonce, it's going to try to solve and come up with a new nonce. So relay creates the required data and sends the data to the client, also signs it. And the client basically checks if the signature is valid. If the signature was not valid, then there's something wrong. The relay might be trying to do a Sybil attack. So this is part of the protocol that you just ignore if a relay doesn't give you a valid signature. If not, then you have to check, okay, if for example, if it's not valid, then you just connect to a new peer. But if it was valid, then you check the proof of work. If the proof of work was not valid, then you immediately broadcast this to the network, because now you really know that this relay is bad. Okay, if the proof of work was also valid, then you only use the 1 out of 100, for example, chance that the data is broadcast to the network. And finally, those who are running forging nodes, they will eventually receive this proof that a Sybil attack has been attempted. And based on the signature, they will know, okay, this is the stake that was related to the attacker. So we just slash the stake. And because the stake just got slashed, now you can remove all the nodes from the network. So I have a visual example of what this would look like. Here, the gray one is the gray node is the seed server. So for example, here it says Sybil attack detected, slashing the stake. And all the links, for example, this message was sent throughout the network, and all the links that were between the proper nodes and the Sybil attacking nodes, they have been now eliminated. And you can see basically it kind of creates like a forking of the network. So all the Sybil nodes go onto their own fork, but since they don't have an actual forging node in them, they will just get stuck on a branch. So any nodes that were not part of the Sybil attack, but because they were eclipsed by this, will detect, okay, I'm not getting any new blocks since a while. So they will try to connect back to the seed node and find another peer to connect to, and they can resume as usual. So this is the basic theory of it. The expected results that I wish to see, or I hope to see in the future: the network should be more resistant to Sybil attacks. Proof of work shouldn't end up doing an exponential increase, similar to how it happens in proof of work driven blockchains. And the reasoning here is because this is now not tied to a monetary reward anymore. This is now tied to the number of transactions happening on the network. So you don't need to increase the proof of work as long as the network can actually handle the transactions. And in fact, because there is no monetary reward, you might even say, okay, now we have 1,000 organic nodes, we can reduce the proof of work requirement. So the attack is still going to be just as expensive. So yeah, the proof of work requirement will go down. We might need to provide some incentive to run relays. This is because we just added an electricity cost in the form of proof of work. So maybe that becomes significant and we might to provide some incentive. And finally, I think that this combined with the AIPs 25, 27, it should be able to give us something similar to proof of work in terms of security and robustness. So that's the idea. That's how it works. If you have any questions, let me know.
Hey, Mac, it's Mark here.
Yeah.
I have a question. When you are slashing the stakes,
Yeah.
could that happen by accident in case of a hard fork, for instance? In case the network splits in two parts, could then half of the network slash the stakes of the other half? And then when the other half comes back, well, all the nodes are invalid because the people lost their stake.
Yeah, so that's why I try to keep the stake that is involved here low. So for example, you notice that I said only 5 ARK is needed for the stake. So I think I mentioned it here, yeah. So if the address only has 5 ARK, then I don't think the relay operators are gonna mind it that much, especially if they are actually getting some sort of reward for running the nodes. But also I would like to point out that if there is a case when a fork happens and you basically need this AIP basically allows you to create an algorithm that resolves forks. So for example, if you notice here, the main goal here is to enable fork resolution here. Yeah. So if you have a case where such a fork exists, we could add a rule, for example, that the value provided should have been at least X blocks old to basically eliminate this scenario where you could get a natural fork in the network and you would punish unnecessarily for that. So what you could do is you could have sort of like a milestone or a rolling milestone that would say, okay, if I get a Sybil attack that seems like it's drawing from data that was not in the fork, or if it was in let's say 50 blocks or before that, then I really consider it a Sybil attack. Otherwise, I think this is okay.
All right, thank you.
Yeah. So any other questions?
Yeah, did you consider any prototype implementations?
So not yet. But I can think about it. So right now I was only thinking about, okay, if there are some things that I might have missed here. So I wanted to get some discussion going on this and get some feedback from the others, because it's always possible that I miss something that the others can see. So once it's once I'm confident that, okay, there are no issues here, then we can, I think, continue with the implementation.
It would be interesting to see it on maybe a smaller scale where we could test or simulate some Sybil attacks and see how it reacts. It actually, we wouldn't need so many computing power at all.
Yeah.
Very nice. Anybody else got any questions? Fix?
Yes, I have 2 questions actually.
Sure.
First, it's a remark. I think you are trying to solve 2 issues. Maybe it would be nice to decouple both parts. And there is a reason why for that, and this is my following questions afterwards. I say there are 2 issues. It's like, first issue, how to prevent Sybil attack. Basically, having some nodes that are faking some kind of chain and trying to get to synchronize with them the status of the blockchain. And the second thing is being able to the first part is basically similar to how do I accept a new node in the peer-to-peer network, because basically one node is basically is having a peer-to-peer network. He is classifying the nodes, the peers, in 2 categories. One are all the peers, where you basically send the data, and one is a subset or some kind of subset categories of good-looking peers. And these good-looking peers are used basically to perform some kind of statistics about the status and maybe try to rebuild and everything. That's the first thing. That's the first part. And the second part, which is more complex to me, is how do we rebuild quickly when there is a fork? So basically, we have a fork. We have 2 chains somewhere, and we are trying to come together with the same solution, basically. The same good solution. And I think the second part is more difficult, I think, because then you have to put.
You're kind of right. But I describe how to solve that in AIP 25. So maybe we can have another session in which we go over that and discuss that.
Yeah.
So I have already presented what I think should work for doing fork resolution. And I think it should work nice, especially now that we have a Sybil resistance mechanism. So I think we have everything we need to implement this and get it working to the level that, for example, Bitcoin is able to do fork resolution. So,
but the thing is that slashing solution is a fork resolution measure. If you add a slashing, it's basically you're trying to add to the consensus. So I would not expect this kind of slashing mechanism in the part of basically countering Sybil attack, you know, because slashing is on the consensus level, and the first part.
Yeah, I guess I could agree with that, but I just wanted to add everything that is relevant to this AIP. So, for example, all the changes that are necessary here. So, even though this is not like a peer-to-peer level thing, it makes sense that I mention it within this context because that's part of the mechanism. That's how it works.
Okay, yeah, that's the first thing. So yes, the question basically, actually I find it interesting basically, but then after you, when you say, because the thing is that if you merge both, then after you have to say, oh yeah, but I put only 5 ARKs because if there is some slashing, there is an issue for fork resolution. I think decoupling both, I think is quite interesting because in the end, you don't need to slash if there is some guy trying to make a Sybil attack on the network level, peer-to-peer level. You don't need to slash them now. You just need to remove it, and that's it.
Yeah,
and
but so yeah. So
yes.
So you have a point, but if I, for example, go back to this here, the point of adding the slashing condition and the linking of an actual account with a stake to the peers is that, for example, in a Sybil attack, the definition is that one person is driving more than one nodes. Yeah. So the slashing is there because if one person is driving more than one nodes, then you attack at the root of the problem, which is the actual individual, not on the individual nodes. So for example, the way you are describing what would happen is you would take out maybe this node because you will detect that it provided you with bad data, but all the other nodes here would still remain in the network, and the Sybil attack basically isn't countered. So this way you basically isolate all the attacking nodes immediately and in one stroke.
Yeah. But I believe that in the end, you don't need slash for just being able to register good peers at some point because basically if somebody has enough stake, for instance, you could instead of selecting the nodes according to the fact, I don't know, they are forging nodes or whatever. What you can do is basically selecting the nodes with the most stacking token proved. So for instance, you sign with your address and you have, I don't know, 10,000 tokens.
So you mean with some sort of a reputation metric, yeah?
Yeah, some kind of reputation based on the stacking. Because it's like proof of stake, you know, the more stake you have and the less probable.
And in your solution, you would slash the reputation basically.
I'm not sure we should go up to the slashing.
Because the problem
maybe it's a good thing, but I don't feel it's useful for this case to go up to the slashing.
So I basically think of
because
this as
you could devise some kind of different attack, basically trying to push network to fork so people get slashed regularly. So yeah.
Okay.
Just like providing an incentive to attack the network.
Yeah, I mean, we can definitely think about alternatives here. Yeah, but my point was that this is a double burn mechanism. So if you try to attack the network, you lose value in terms of the electricity you spent. You lose some money, and also you lose some money in the form of the stake that you just lost. Yeah. So if we want to remove the stake, then we have to add something equivalent in the system that basically forces people to really second guess, and also we need to find a way in which basically just with one violation of, for example, giving you bad data, we can detect all of the nodes that are belonging to the same person and remove them.
Yes. The thing
So
is
yeah,
that I
we can think of some alternate method for this, but the one that I came to and I think should work is based on stake. Yeah.
Yeah. But I think
okay, so I'm gonna stop my presentation now.
No
if
problem.
I can see the button here.
I think the proof of work thing is kind of interesting because you could even, for instance, try to increase the proof of work when there are more and more people, you know, to make it more difficult to hijack the network peer-to-peer with new peers, with many peers. But okay, yeah, good.
So I'm not sharing the screen anymore, yeah?
Yeah, no.
Okay, perfect. So any other questions?
Okay, just one question. When can you provide more information about what it means valid? It means that signature is verified and there is at least 5 ARK or so many ARKs in the public wallet related to the public key or something like
so
that.
the issue here is that, for example, if it's an SPV wallet that's trying to do this, or if somebody is making an API request, then they don't have a copy of the blockchain on their own. So they can't verify that you actually have the 5 ARK. Yeah. So what do we do in that case?
Okay.
Yeah. What we do here is we use the 1 out of, for example, 100 transactions. We just forward it to the network, and the network checks for itself if there's actually if the data was valid or it was not valid.
It's a bit more difficult because this is where, for example, Merkle tree or whatever.
Yeah.
They are trying to do that in Bitcoin as well with Neutrino or these kind of things, but it's more difficult if you are as SPV client. Yes.
Yeah.
Okay. Thanks.
Okay. So that's all from me. Yeah. Thanks.
Yeah. Thanks, Mike. Yeah. Very good.
Mike, thank you very much. A good presentation, very detailed. So we'll be digging up a bit more on it. I already see Fix being quite keen on it. Okay, do you see my screen? No. Yeah, now it's okay, I guess. Yeah.
Yes.
Can you hear me?
Good.
Yeah. Good.
Yes. Okay.
So regarding new AIPs, so we'll be introducing now. We'll be talking about the bridge chain registration types, which is basically AIP 103. So the idea is that the team in a company will be able to issue a bridge chain or business registration transaction. So this will be new transaction types. Think of them similar as we have now delegate registration, but meaning that this will be a business that's operating, someone that's launching a new chain, somebody that would like to have powered by ARK logo. So actually this will be basic transactions that will be stored on our mainnet, and idea is to provide more information about that bridge chain. So it's we're introducing 4 transaction types. First is business registration type, meaning that official business or team can register and present itself. So it will enable them to provide additional information about this business. So the fields, so we can see for the business, which are some kind of ideas to be unique, but not all of them are required, because it depends if you are official business or just a startup or a team starting to build up your own reputation. So you can also update this information later on. So it's mostly a repository of teams and businesses running on the ARK network. And the idea to have a business registration transaction type is then that only business registration and the companies or teams that are registered can further then issue bridge chain registrations. So one business can have more chains. These chains can be registered, and of course a bridge chain is which is the most important part, because now we know we have quite a few forks or bridge chains, but we never get a lot of detailed information about them, like which seed nodes are updated or how we could directly communicate with them. So inside this registration transaction type, they will provide additional information, and the most important part being their Genesis hash, and of course an initial array of seed nodes from where all the light clients can then directly connect to that chain registration, or our wallets can auto-configure from there. So it will basically start to grow a network of bridge chains where all the information will be stored on the ARK mainnet, meaning that any light client or anybody that comes in can get information about this chain, connect to a seed node, start, let's say, verification of peers, and in the end, it will be possible to actually develop some kind of smart bridges or router plugins, because everything could be discoverable via registration transactions which are on chain. So this is mostly it. I mean, we can discuss about different fields. There are some rules similar, basically, that names will be unique. Only a bridge chain registration can be issued only if this address has registered as business before, otherwise not. It will be possible to update the fields, to update the information, so it will be the same transaction with updated data. So less transaction will be used, but of course we have to keep in mind that we don't open too many aspects to transaction spamming. So with the updates will be limited, let's say, to once per 24 hours. What else do I have here? Of course, in opposite to delegate, we'll have business and bridge chain resignation or termination. So if the chain will no longer be active, somebody will have to resign. So usually resignation will have to go from the same address as the business was registered or the chain was registered. So, but it will be possible, because in the end, if somebody else wants to use that name further down the line, and well, we can enable it. So why the reasoning? Opening doors, of course, to new projects, to new teams, to new plugins. So actually further expanding our Power by ARK program. So these chains will be also visible inside Explorer, auto-discoverable from all our wallets. Either it's going to be desktop or mobile wallets. And of course, this will enable the teams or companies to develop and publish their new developments, like being a bridge chain or a registered business, you will also be able to register your plugin. Let's say Mac has developed a new plugin for Sybil attack termination, so he can, if he has a team, he can publish this plugin, and this plugin will be actually signed by the business registering transaction. So it will actually give us some kind of identity, which will in the end be connected with some kind of rating system down the line. So these are AIPs that are still work in progress and are due to come in later on. Okay. Any questions regarding bridge chain registration types?
Hey, Chris.
Yeah, I have one.
Yeah.
Oh, sorry. Go on, Mark.
All right. Thank you, Mike. In the case you register a bridge chain with a ticker, how do we prevent that some joker is going to register all the important tickers on the first day it launches, like BTC, like EOS, like LSK, whatever? Is there any mechanism that we can we put in place?
We were thinking about it. So either we remove the ticker, because in the end, on everything we need are the seed nodes, and the way the core is turning now, you can auto-configure the light client from the seed nodes directly, so you would get the ticker and the genesis information from the seed node. So this is actually, this field would be scraped from the initial registration.
All right,
good question.
thank you.
Well, actually, this is a whole range of spamming the blockchain with some data.
Mm-hmm.
I think at some point, since there is some kind of ground truth data in it, they will need some kind of filtering or some kind of I don't know, entity being able to curate basically all the data in. And okay, I think it's kind of easy to solve, because I think people with stake or with thing can maybe countersign this kind of transaction. So the more signature and the more trustable would be the transaction. And of course, we can maybe decide in the transaction pool that we won't put in the blockchain as soon as there is no, like, I don't know, 3 or 5 signatures equivalent to 1% of stake. No, I don't, just ideas like that. But maybe there is some kind of need, because spamming will happen, that's for sure. For instance, ENS, so Ethereum naming space, has a lot of issue with the spamming, and so there is some need to some kind of curating somehow by the community curating the registration.
Yeah, I mean, one thing we saw this is the role of delegates.
Can you hear me?
Yeah, sure. One
Hey,
thing.
let me just jump in real quick. So when we're talking about curation systems, the ARK Marketplace, we haven't put a lot of details out about it yet, but the idea behind it is that we wouldn't want you necessarily vetting businesses or names directly through the chain. We want a centralized place for you to go and do that, and that's what the marketplace is all about. In the marketplace, people will be able to set up accounts on the marketplace and validate those with their account on the ARK network by using the vendor field and setting a kind of an ID. So once you've validated that you own a business registration on the blockchain with your account on ARK Marketplace using that vendor field ID, it's now associated the two. And then what you can do is we can use traditional methods to allow you to validate like a domain name. So for instance, if you go and somebody has EOS, you could get EOS official, and then you could go in and you could validate with the actual domain address, eos.io, and then you get a little check mark that says you're a verified domain address, so that when people go to you in the marketplace, they see that you validated that you own the identity that you were saying you are, which will help us curate and vet properly the people that are registering things. People are going to go in and register faulty addresses and names, and there's not much you can do about that. But through the marketplace and through use of delegates and other things, we can go and we can provide a way for them to validate and verify they are who they say they are. So we'll probably manage it through that rather than through the chain itself, by doing a validation process through the website.
Yes, I agree. I think we can put just a few things on the ARK chain, and then after delegate all the data and everything on some kind of centralized website. I think it could be a possibility. And I was thinking that one interesting case would be able to register regularly some kind of milestone. For instance, this bridge chain now reached this block with this ID, and it's kind of trustable source of data, for instance, for the status of a blockchain. So yeah, these kind of things.
I mean, we can also contrasign them with our own transaction. Basically, if we're looking at the Powered by ARK program, we can have a wallet that is in charge of this program, and any addresses that are routed up or checked with this wallet are considered as valid addresses, as valid bridge chains. Yeah, that would make it a bit easier.
Essentially, what's the use case intended with this bridge chain and business type? Is basically provide a trustable source of data, right? That's it.
Yeah.
Yeah. Okay.
Essentially, everything we build comes down to the being bridge chained, discoverable on chain, and let's say voted upon or by other architects. Because either we're gonna go from marketplace, registering plugins, or any other new functionalities, any chain will have to be registered inside our ecosystem. So this is where it all starts. So even if you want to connect to their nodes, access their peers, access their updated information, so all they have to do is issue a transaction around chain, update the peers, and our APIs or any other plugins that will be able to communicate and relay this information for different networks. So actually, it's a small transaction, small data we add on the chain, but we get a lot of functionality we can build on top of it and around it. So that's the main reason.
Okay, but I wouldn't have so much data inside the transaction. I think we can public key and being able to be countersigned by many different keys would be a really good beginning. Because for instance, just say, I don't know, Genesis
Basically, we
hash.
just need the seed nodes. Genesis hash was
But
added.
let's say GitHub is closing, or or doing stuff, or email is changing, or whatever. You need to send a new transaction, that stuff.
Yeah, why not? I mean, how many times you change it if you're a business? But these are actually optional information, so they were just added as optional, and the seed nodes are the only required. So, and the ticker would go out, as Mark also suggested. And Matt, thanks for jumping in. Anything else regarding bridge chains? Calling once, twice, Bert?
Okay.
Okay, let's see what's next. Yay, hash time lock contracts. So there has been a lot of talk internally, a lot of talk about how do we provide this functionality on ARK network. So basically, we are really happy with the new generic transaction interface. Adding new functionalities to our core is really seamless because everything follows the, let's say, the predefined interfaces. So now adding new transaction type and expanding core goes like with rocket's speed. So one of the first transactions we're adding from new scope are hash time lock contracts. So I guess more or less you know them all. So I'm not sure how deep into detail we want to go, but this is the first step toward, let's say, towards atomic swaps, toward cross-chain contracts we want to go by introducing 3 new transaction types. Basically, one transaction type is HTL lock. So meaning I will lock funds from address A to B for this amount of time. And then there will be 2, let's say, sub-transactions that will enable users either to claim these funds on one side or on the other side, or to issue or to start to issue a refund if the funds weren't claimed in the same time. So the only shared data that is very important between all the contracts is actually the hash, so the secret. So if you look at this basic cross-chain scenario where actually Chris and Lars are trying to exchange ARK for credit, and basically from the start I want to send 300 ARK for 3,000 credit, and I issue HTL lock transaction with a hash of my secret. So I don't give out my secret, I hash it and I put the hash into a transaction. So only I know the secret. And then on the other side where we made an arrangement with Lars. So Lars is doing the same lock transaction, but he's issuing, let's say, 3,000 credit to my address, and he's using the same secret hash. So that's basically the essence of the contracts. And now he can actually then, when I see that he issued the same transaction with the same hash, meaning that I can now claim this transaction by revealing the secret. So, so now I'm going to claim the transaction from Lars, and I will, inside my claim transaction, I will actually reveal my secret, meaning that the claimed funds will go to me. And when this transaction will be processed, either on credit or the chain I'm doing a contact with, Lars will see my open secret, and of course he will be then able to claim step 4 on the picture actually, so 300 ARK that he will receive. So actually a cross-chain swap scenario is related with 2 sets of HTL locks and HTL claim transactions. The proposal is on AIPs. So in essence, HTL lock transaction will introduce new fields. The base fields will be from the AIP 11, and additional fields will be the secret hash, which is the hash of the secrets we're talking about. So that's the most important part. The recipient, then there's the expiration. So how long do I want to lock these funds, and the amount of funds I want to lock. So we had a couple of discussions about expiration. I will leave it until end of the presentation, and we can open it. Essentially, the question is, do we want to address expiration in block heights or as absolute timestamps? New fields will be added to wallets, so basically the number of locks, because the user can have more atomic swaps, more locked transactions open, so we have to keep track of the locks. And of course, we have to keep track of the locked balance, because even if my funds are locked, they are still mine, so they don't need to affect, let's say, the voting stake. Verification. So actually, in the verification, these two fields will be used. So the lock balance gets, if you're talking about lock transaction, the lock balance gets increased by the amount and reduced by the fee. So I don't want to go into any more details based on the time into these factors. And of course, more important thing about this transaction besides expiration time and attacks are also fees. So limit the number of fees, because we don't want somebody or some network to spam us with let's say 1,000 of HTL lock transactions. So we want to limit either the number of open locks or adjust dynamic fee calculation. So the more locks there are open, the more expensive fees are for the sender. So this is second discussion topic I would like your feedback on. Then there's the claim transaction. So basically in the claim transaction, all you have to know is the unlock secret, which was made public by one of the participants of the hash time lock contract, and the ID of the transaction that I want to unlock. Okay, maybe important factor here regarding the fees. So if I'm claiming the transaction, so there were a few options regarding how we want to manage the fees. So if my wallet is empty and the transaction cannot be applied because I don't have the funds to pay the fees, so actually in the claim transaction, the fees are subtracted from the claimed amount. So that makes the transaction then processable. It can be applied anytime, and the funds don't stay locked. The refund transaction. So the refund transaction has a few rules. So you have to know which transaction you want to refund. So, and the basic rule is that the expiration time has passed. Of course, regarding this expiration time, we are again related to either are we talking about blockade or are we talking about timestamp, and also we are open to a few attack vectors, especially because we have not yet introduced moving checkpoints. So meaning if a fork recovery or some kind of rebuild is triggered on one chain and funds were already claimed on another chain, so this could open up doors for double spend attack. So we need to discuss the grace period. So how long do we wait? Do we wait at all? And what is the grace period around, let's say, expiration time? If expiration time was, let's say, at 10,000 blocks, do we wait a random 1,500 blocks around it, or do we just process the transaction? Sorry, guys. Yeah, so this will be a quick introduction. So more information is on the link. But actually, so as I said already for the presentation, so I would like to open discussion regarding these topics, and feel free to ask any other questions which are besides the open discussion. So we want to have this functionality as soon as possible on our mainnet. Of course, there will be a testing period because it will open doors to so many new functionalities besides cross-chain swap, a possible decentralized exchange, whatever you can think you can do when you lock funds. Questions?
Yeah, I have a question. Is the refund transaction actually necessary, or would it be enough, like when the transaction expires, that at that point, if funds are still there, we just send it to the wallet that sends to that created that transaction?
Yeah, we had discussion if we do it in an automated way or not. But actually, as this is, in the end, this is interaction between two entities, so it's a decentralized interaction, A to B, so there's no, let's say, exchange or factor in between. We wanted to leave it to somebody to trigger this refund transaction. Either it doesn't have to be the sender, but it should be an entity that will trigger it. Either it is, I don't know, if you buy something in the store and you reserve your funds, and you didn't receive the item, and then let's say the store owner will issue a refund for you. But to do it in an automatical way, it opens a few doors for attacks because of the precise expiration issues around expiration time. So if the time is very close to each other, it could open a possible double spending attack vector. That's one of the things.
The thing is that there is another attack, is that there will be a race of delegates to send a transaction with full fees, the full balance on the fees. Which leads to maybe another remark now, looking at the presentation. Maybe we should make the HTLC claim and HTLC refund with no fee, because anyway it will happen. And even more than that, in terms of optimization, you really want that to release the memory footprint and release the lock as soon as it expired, either by a refund or to claim it, which means in the end, I think we could price anyway the fee on the HTLC lock, but claim and refund could be completely free in terms of fees, and which will solve the issue of applying fees to the sender, to the recipient.
Yeah, if it's empty. Yeah, it's an option. Yeah, I agree.
I think it would be better and a lot simpler to deal with.
Yeah, makes sense. I think we had it in initial specs. Yeah. Anything else?
So how easy is to make a proof of concept quickly with this? I think it can be rather quick to make some kind of something testing. Yeah, implementation.
Yeah, I mean, implementation is already in progress. So based on the initial specification, I guess it's not yet running on .NET. We started to work on it previous week. So, but it's hard to give days. But I say, I'm confident we can say in 1 month we can have some testing on .NET for sure.
Yeah, I think so. Yes. Yeah.
Because again, everything relates back to a generic transaction interface, and it's really awesome.
The other thing as well, I was thinking that to be able, instead of locking parts of the balance of a wallet, is to lock everything or nothing. So you have only one lock ID per wallet maximum, and then in the end you can imagine something like a longer lock. And if the transaction is getting longer, the person can augment the locked wallet with the time. We just sending transaction inside the wallet.
Okay, there was a reason why we chose this structure, and the reason actually is also we were looking at Bitcoin, Ethereum, and let's say the Lightning Network specification. And the specifications are pretty much aligned with ours, because step 1 would be to have HTLX, HTML transaction inside our ecosystem. But based on the specification being very similar to Bitcoin and Ethereum, a new plugin or a listener could issue actually cross-chain swaps outside of our ecosystem. So that's the reason, splitting it in 3 types and so on. So.
True that. There is a risk of breaking the way of doing atomic swap with other cryptocurrencies.
Yeah, and another thing is keep it standardized. That's one very important thing, and a lot of logic, let's say, which is very important in the end, like front-end development, graphical interfaces. This is where a lot of complexity can be hidden based on, again, if you look at back the bridge chain registration, we did a bridge chain registration. We know which seeds are, so we actually know how to relay HTL lock transaction from ARK to credit, and of course we also know how to listen on ARK on when the lock transaction was processed on the credit chain. So again, you're in one line and you're just listening on both sides. So yeah,
sensible to me. Yes.
Yeah, Chris, this is Mark here. I'm pretty happy with this. This will make my life a lot easier. in the months to come when I'm starting building these kind of transactions. Regarding the expiration time discussion, I would opt for the block height because it's a more natural way to look at the dynamics of the network. The block heights are more predictable than the absolute timestamps. So I would really opt for that option.
Yeah, true. From most of the core developers was actually for this, basically from exactly what you said was the issue. So more predictable, you don't have to calculate the timestamp to block height, and you know where you are. So another discussion on this was like, okay, but you're on ARK and we have 8-second block times, and now we switch to Credit who has 30 seconds block times, and we switch to, let's say, Ethereum, we're talking about 10 minutes and so on. So different block times, again, change the dynamics between, let's say, users exchanging funds. So maybe absolute timestamp is more friendly toward users, where actually height is more deterministic toward, let's say, block confirmation times. So it's A or B. And I think Ethereum does absolute timestamp also. Yeah.
Bitcoin is doing block height. The thing is that Bitcoin is doing both actually. So it's a two instruction. I think maybe we can have a flag to say, okay, count the expiration in absolute timestamp or count the expiration in block height, and see what's the best in the end.
Or do both. And then let the latest one expire. So in case the absolute timestamp is tomorrow 8 a.m., but the network stalls and the block height that we expect at that time is going to be at 10 a.m., then expire at 10 a.m. So give it the longest of the both. In that way, right? You have, in case the network goes faster for whatever reason, then the absolute timestamp stands. And in case the network goes slower, then we have the extra block heights.
Yeah, it could be some kind of flag that just tell how you register the expiration. Maybe you can put both, and let's say the first occurring is valid or whatever. But I think it's some kind of things that you may need to give the possibility to the user in the end, because maybe users will see different things differently.
Yeah, but again, we are there going back to the graphical user interface. I mean, nothing is set in stone, so definitely the base specification are 98% done. So let's push this forward, and then we can still do another follow-up and see what works best actually in practice. So.
One question for me. How easy do you think would it be to interact with Bitcoin or Ethereum, for example? Do we need some sort of smart contract on there, or is it like a modification of the wallets on their ecosystem? How easy is it to get interoperability with them?
Well, actually, as I said, the structure of the HTML contracts is similar, so we would actually have to listen to their chains. So I see this as listeners on their chains, and then giving feedback information when lock was processed. So if a lock is processed, then you can see it, the transaction being confirmed and inside block, and also the secret is being available. So.
Yes, basically the thing is that they are mechanism, so which means basically that the secret hash is the thing. As soon as you have the secret hash, you can unlock on the smart contract on Ethereum, unlock HTML contract on Bitcoin or on ARK or whatever, or ARK chain.
Yeah, I understand that. So the standard that you're following, of course, you're following a standard, so that means it's compatible there. But what I meant was that, for example, right now the Bitcoin wallets that are being used, if, for example, there is a wallet that already allows you to interact with some other blockchains, what do we need to do to make sure that they are easily able to communicate with our thing?
Oh yeah, I don't know if they have some kind of primitive basically to register a new coin. I'm not sure. It would be nice to understand if there is something. But I think in the end, for Bitcoin and Ethereum, it will be binded into our own wallet, I guess, at some point.
I mean, also, if you look at the Lightning Network, how they do it, actually, they're listening to transactions, they're listening to amounts they are locked. So no matter what's the wallet structure, you are just listening to that wallet, meaning sender public key, and his transactions rolling out. So it, like listening gateway or a plugin like Core HTLC Bitcoin, Core HTLC Ethereum, we should pull that information in. So.
Yeah, I understand that. The reason I asked was because Lightning Network is sort of like a protocol that you need to run a node for. But for example, our users might be using some wallet or something. So the method of interaction here is very different, and we need to think about that.
Yeah, I agree, definitely. Yes. Lightning Network lives on top of the Bitcoin transaction. So that's what I said. We are sticking close to overall specifications. And when we get this done inside our ARK ecosystem, we'll look into more details how to integrate it. Yeah.
Well, for Lightning Network, we need a special way of locking the data. I mean the coin, because it's a special payment channel.
Yeah.
And that's where SegWit, yeah, it's based on the SegWit and everything. So yeah, we likely need to have some kind of equivalent of segregated witness on ARK as well. But anyway, yeah.
Okay. Any other questions?
Yes, getting back to the using timestamp versus block height, could we just have an option in the time lock transaction to select one or the other? Might default to block height, but you can select time stamp if you have something that's critical, time critical, say not a real-time event somewhere.
So you think you could have it configurable? Either I issue a lock with yeah. I think this is something we started with time locks in AIP 11, where you could select either you want to lock your funds with absolute timestamp or block height. It can be done. We have to think about, let's say, okay, flexibility is very important. So if some users want to do it and build something on top of it, yeah, I actually think it's a good idea. Nothing against it. Thanks, Mike.
Sure, thanks.
Okay, so moving on to the last AIP, authentication scheme using ARK. Fix.
I guess I should put my presentation to be able to...
Or I can switch the slides, whatever you want.
Switch. Okay, yeah. Let's switch. So authentication scheme using ARK. Okay, so I have put AIP 97, but it's an issue on AIP network repository, so it might change in the end when finalized as a PR. What's the purpose of authenticating is that I think it could be even linked to the first presentation of Mac. Basically, is to be able to leverage the cryptography used in ARK and Bitcoin to be able to authenticate people. So pure authentication, so nothing related to blockchain, and as well to be able to prove the ownership of an address, of a wallet, and then after to be able to make some kind of computation on the server part, on the authenticating part about the balance, the history, or transactions inside this wallet. I'm reusing AIP 26 URL scheme, extending basically. And it's basically based on a few interesting experiments in the community where, you know, people were authenticating for voting, for instance, the vote in ACF. And the thing is that the schema I'm proposing right now works as well for other cryptocurrencies, not only for ARK. So it could be a discussion later. So next, Chris is gone. Oh yeah,
there you go. I'm here. I'm here.
What's the purpose of authenticating is that it will be a way to provide a passwordless authentication scheme. So you won't need to, for the server to store a hash of a password or salted password or whatever. There won't be such thing. It will be only the public key will be somehow stored on the server, but nothing else. Which means that in the end, it could be tamper-proof to any hack of central system, where you have heard lots of passwords have been leaked, and then after putting on danger all your assets in different servers, in different parties, because you are basically reusing same password and everything. It could be merged with message signing, but I don't remember why I put it here, but I think it's more in the conclusion to put that. It uses random nonce. Basically, when I explain it, the reason why is to mitigate pre-image attacks. So to prevent people providing some kind of hash, which is basically prepared in a way that can hack you to, making you sign a transaction for something else. I have not provided implementation details yet because, for instance, you would need, for instance, to salt public keys. So if your database is being hacked, it's more difficult to be able to match public keys from different hacked database. And use of HG wallet for the user, so it's prevent from ID leakage as well. So it's kind of more on the implementation part. On protocol part, it's rather simple. So basically, the user is requesting to authenticate to a server. The server is sharing you with some data, and you are basically signing the data smartly, and the server can verify you are actually this public key. That's rather simple. Next. So request, basically the request is sending your public key and the network you want to authenticate against. For instance, if you want to authenticate against ARK, credit, because we talked about credit before, but Persona, whatever chain are going around using ARK, or maybe Bitcoin, you can put Bitcoin or whatever. So some kind of network identifier. The reason why is that if you want to provide some kind of, it's not written here, such a return, some kind of KYC, the server can just inspect the blockchain and see, okay, your history is clean, or your Bitcoin address is kind of existing with some kind of coins, or yes, this public key is not like some kind of public key of Bittrex hot wallet or whatever. So basically, you are trying to make some kind of good assumption about who is going to connect to you. One thing interesting is that you don't need to register using this. Sending a public key is like registering. So you could even provide mechanism where people don't need to register. They just need to log in first time, and they can be identified as with a public key. And this message, of course, is sent through server IP. So the server answers basically with a provider identity and a nonce. Nonce is here, of course, to prevent from attacks for reusing authentication or pre-image attack. But the thing is that it should be pseudo-random. It's not like a nonce, incremental nonce or whatever. It's just a pseudo-random. It can be used as well. This nonce can be used as some kind of session ID, so you can reuse the people. In further communication, you can reuse this kind of data as a session communication session ID. There is one thing is that B, just before, again, back, just back. Yeah, B is some kind of ID of the merchant, but it does not prove anything. This protocol does not want to make assumption about the fact that you are communicating with the right person, which means that you are still sensitive to man-in-the-middle attack, which means that you should use this scheme through encrypted communication, because otherwise you may come with some kind of man-in-the-middle attack scheme. So it's not an open communication protocol. It should be the channel should be encrypted between A and B. Yeah, next. And proof, basically, you send a new nonce. The reason why is again to prevent from reusing several times the same communication ID, but it would be more a server attack to the user. But that's thing. But okay, so same nonce2 is pseudo-random, and signature is basically signing the whole message before. And as soon as the server can verify the signatures, the success of the authentication is okay. The server does not need to save any information except nonce1 for some kind of session ID, or maybe some kind of hash. You can use the hash of the whole stuff as a session ID. Nice. Next, sorry. So if you can see, it's only using cryptography. So I was thinking that maybe we should use another name because to try to propagate basically the idea in different projects and not only ARK. So I was proposing maybe some kind of another name for this kind of authenticating stuff. It works for basically any cryptography working on Ledger, just to make it simple. The thing is that, okay, I think at some point it should be included in SDK, so all the language implementation should be able to handle this if we want to go further on this integration in different stuff. What can be really interesting is to perform some kind of decentralized Auth protocol. Auth is a standard to be able to share your credential between different scheme, and I think it could be interesting to have some kind of Auth system on top of this. And of course, I think integrating in Ledger is a requirement. And as well, the thing is that this solution, since you don't need to register on a website, you need to open basically you need to do on this on your side, you need to create a key, a public key, which means that you can have a wallet handling as well all your history connecting to a correction in different parties, and you can review them, you can maybe close them or whatever. So it would be really interesting to be able to put back in the pocket of the user their authentication on basically internet. So yeah, I think it's a final slide. If you have questions.
Yeah, I have one question.
Yes.
So this API is primarily to integrate this part in the wallet. Like so that the wallet understand when you click on a certain button on the website that then like it's, let's say, signs that nonce. And
yeah, exactly. The thing is that when you click on logging on the website using this kind of scheme, it can open up the wallet, present you the data, and you can just decide to go further and sign it basically.
Yeah, cool. Because this is what I was exploring on arkdelegates.io. So where yes. You claim an account, I like send the nonce, and then they sign it, and then I just verify with the public key. But yeah, I was also starting to look at how this can be like put into the next level so that we can actually make it easier for anyone to log in, because currently it's a bit like user has to copy stuff and things like that. But yeah, cool.
You will get basically a central wallet to be able to handle all your connections this way. Basically, when you click on the website to authenticate, it will make the request. Then after the website will send you back the challenge, and when sending back the challenge, it will open up your wallet, presenting you the challenge and signing and sending back to the website the signature and finishing the authentication. And then after, your wallet will track all this kind of authenticating of all these authentication.
So one more thing that would be needed is actually passing a callback URL, which the wallet would then call to actually authenticate the user.
That's true. Missing. Yes, that's true. Yeah. It's not done yet, but it's missing. Yes, you're right.
Yeah, just thinking out loud. Cool.
Mm.
Okay, cool. Thank you, Fix. Any other questions? Okay.
Hey, Kristjan, I have one question.
Yeah.
Integration into the Ledger app. As far as I know, the Ledger doesn't support signing of messages yet. Is that correct?
The Ledger is now supporting. I don't remember the status. I have not used the Ledger to sign messages. I think it's already in the Ledger app for signing messages, but it's not yet binded in software, in a wallet or whatever.
All right. Yeah, I haven't tested that recently, but when I was working on the JavaScript CLI, I couldn't sign with the Ledger because the app was lacking functionality for that.
Yeah. I think that on the Ledger we have a lot of change with the new NanoX, the new firmware and everything. So we were more focusing on this, but I think it's already, the pull request has been accepted and already on the Ledger app, but we have to verify this. Yes.
Yeah, I think Vasil was actually doing this on the Ledger app. Yes. I will follow up with him and I will connect you two guys because he was actually signing messages. I know he has some issues related to the length of the message, but he was doing it via the app. So I'll connect you two later and we can check what's the current situation on that.
All right, perfect. Thanks.
Okay, and last but not least, so if you remember at our previous dev meetup, we introduced tier 0 projects. We will be having more and more tier 0 projects because, of course, we rely also on the community to help us build our ecosystem further. And one of the first tier 0 projects was ARK Tipper by Mark. Mark is also here today, so he's been very active. And I see, Mark, that you can't wait for the hash time lock contracts, the same as we are. Anyway, I will give more words to you so you can update us on the progress of the Tipper and tell us more what was your experience with the tier 0 projects, lessons learned, best practices, and whatever you want to throw in.
All right, thank you, Chris. I haven't actually prepared anything, but by head, tier 0 is going pretty good. It's very pleasant to work together with you guys on a more deeper level, and we already see the fruits of this coming into the time lock transactions, etc. So it's expanding in both ways, right? I give you new ideas, give me new ideas, and together we're going in all these directions. And a lot of things are hooking up together in a sense that it all works towards the end product, not just ARK Tipper, but also for the whole ecosystem. Regarding what I have done the past 2 months since we started, first of all, last month I rewrote ARK Tipper from scratch into the TypeScript and created it in a more flexible framework. So it's easier to add different framework, different platforms, different forms of transactions, etc. So flexibility was a big one, and I made it more robust. And this month, it's all about adding the first, second platform. In this case, Twitter, which went pretty good. There's a lot of usage, John McAfee has received tweets with ARK, as far as I've seen. I heard some people were going to Twitter, were going to tweet ARK to Trump, which they haven't done yet, which I'm not sure is good or not. But yeah, the exposure for ARK has been good, I think. And at this moment, I'm working on implementing N+1 service availability, so I can add Tipper on more than one server to make the whole system robust. I've created, coming back to the authentication scheme, a similar way to authenticate servers when they claim to execute a transaction. So a transaction can only be able to be executed once. So if I have, say, 5 servers all receiving the request to send ARK from A to B, then only one of them can claim to do the transaction, which I'm using also a signature for that. So that also is moving all together in the same direction, right? All these new things that we're going to do already are being applied on intuitive levels. Okay, perfect. Yeah, nice to hear the progress. For next month, right, the big one is going to be JSON API, so other people can add their platforms into ARK Tipper infrastructure, and that will also rely big on authentication, because a platform will have to register, authenticate itself, and then authenticate each request it's doing. It's sending to the Tipper backend. Yeah. So yeah, we're going ahead. We're going good ahead, and we're still on schedule, which is also important. Yeah, very much. Yeah, I mean,
yeah, that's nice. Actually, I've tried it on Twitter. Just 2 questions. Two questions, 2 remarks. One, that's true. If ARK Tipper can be used in different platforms, more platforms, I think definitely it would be nice. You know, reusing basically the same. I don't know how it's possible, but basically being able to reuse the same address from different platform to the other.
Yeah, I didn't want to do that because then we're gonna have people saying, I have username cryptology on Twitter, I have username cryptology mark on Reddit, and then somebody else has cryptology on Reddit. So that's gonna be a slippery slope. So I specifically didn't do that for that reason.
But then in the end, you could reuse this kind of authentication schemes that I have just provided. Just prove you are the same person from the same wallet. It could be even an empty wallet or firmware wallet, and you prove that you are the same person from the same public key. That could be.
Yeah, but then you have the problem that I don't know the receiver, right? So you can send ARK by tweet to a new receiver who doesn't even know about ARK.
Oh yeah, but this you have to create anyway. Yeah, I agree. You have to create it anyway. Yeah, that's true.
Yeah,
that's true. Which brings me to a second remark: that imagine that your ARK Tipper is working like mad, and you have thousands of transactions per second. I guess it would be a bit too much. Maybe you have to think, and maybe it's linked to be able to merge transaction somehow. But yeah, maybe we have time before that. But I think above all, if you want to tip even small amount, like 0.1 ARK or whatever, it might be interesting to provide some kind of layer 1 facilities where basically you are doing all the teeny exchanges, and then after sometimes reflecting it to the blockchain. But it's just maybe it's
we could look into that. The whole idea from the original setup of ARK Tipper was to kind of show off that we have fast block times and that we can do everything on chain.
Yeah. Okay. Yeah. Okay. Yeah. It's just asking. Maybe we will wait years before we will need that anyway. Okay. Nice.
Just a comment on something you said, Fix. In order for him to be able to merge transactions, he would need the multi-payment protocol and the multiple receivers. So, yeah.
Yes. Yeah, that's
We have
it,
it.
basically. Yeah.
We have it
Yeah, we have this. It's already
implemented.
basically,
On that.
yeah, it's
2.6
implemented, but it's not yet
on mainnet. Yeah,
not yet on mainnet. Yes.
true.
Okay.
But
By the time it's an issue, it'll be live.
yeah,
Yeah,
that's
I
for
guess.
sure.
I guess so.
In September. Good, Mark. Thank you for your progress.
Don't give dates, Chris.
No,
Jesus,
I
what are you
didn't
doing?
do this, which I didn't say either.
Yeah.
Yeah. Okay, guys. Let's wrap it up. If nobody has any further questions, I would really thank everybody for presenting, especially Mark and Mac from our community. And yeah, let's keep the ball rolling and let's keep pushing forward. New AIPs will go into implementation. We would really love for you guys to think about them, maybe add some comments on our official repository or questions or in Slack. So the more we communicate around this, the better the ecosystem will be, and the better will be the final implementation. So again, yeah, thanks guys, and talk to you soon.
Yeah. Thanks, guys. Thanks, Chris, for setting this up, and see you next time.
Yeah, thanks for your time. Bye-bye.
Everyone.
Bye-bye.